Zach, congrats on the first. Making sure YouTube is up too. All right, we're in business. Okay. I'm on green. Get me off green. Okay. Um. Oh yeah, but Zach, listening to your I guess like rant about like education and textbooks actually did get me like interested. Like I feel like we just need to have like more conversations like that because I just think they're kind of interesting to hear. Um. Yeah. So this is mechanics. I finally got around to reading chapter 7 of the mechanics book on torque. Winner, winner, chicken dinner. Yep. And so I want to, if I can today, it would be nice to get through these 8 foundational problems. If people start asking questions, though, we're almost certainly not going to have time. But let's at least do what we can here. And whatever I can get done today, I'm probably just going to take it as good and then move on to chapter 8 by the next time I stream, hopefully. I still haven't quite gone through the general relativity chapter 2. I have a little bit more reading to do there, but I think this is also important to at least do a little bit of. Um, so 7.1, prove the parallel axis theorem, stated in equation 7.5, which I copied down there. Here to deal only the special case where the object is planar and the axes are perpendicular to this plane. The reasoning in this case has all the ingredients of the general proof. Hint, right, the coordinates of the general point in the object is the sum of the coordinates cm plus the coordinates relative to the cm. Okay. That probably isn't that hard, but I need to figure out how to phrase this. So maybe I should have brought figure 7.2 in as well, which it's not too late. And we also have 2 definitions of moment of inertia, which are probably helpful to have. We have the discrete definition. And we have a continuous definition. I don't know if one will be better than the other, or if you should technically be doing both. We'll just have them both for now. So I guess it would be better. I guess in trying to prove this, we should name a point P and then like what we want to do is take a generic, like we can even use this exact figure here, put a center mass somewhere on it, put a point P somewhere on it. And probably start with the right side and end up with the left side, hopefully. Side toes? Euler, when he died, simply collapsed and said, "I am finished." When Erdos told the story, somebody callously remarked, "Another conjecture of Euler was proven." Are you also Cytos, like Cytos? Or does your names have to be pronounced the same? Yeah, okay, okay. um, the moment of inertia IP of not necessarily planar. Just saying M is mass of the object D. Oh, hey, Cook. R equals Cm plus D expand. Wait, R equals RCM? Oh, okay. So I should be, these are vectors, right? Actually, the moment of inertia is a vector too, right? Am I crazy? Oh, I might be crazy. No, I am crazy. I'm thinking of torque. I'm thinking of torque. Moment of inertia is not a vector. Get rid of those. R equals R Cm plus D. The integral in the linear term, the integral over the linear term in RCM will vanish by definition of center of mass. Yeah, I'm trying to figure out, like, uh, the perpendicular, like, the thing that's tripping me up is R is supposed to be some function representing the distance from each piece of this thing. Well, I guess we're talking about to the point P. Oh, maybe I just answered my own question. No, it didn't. Like, I'm trying to figure out why this would be true. Um, because I was just thinking that, like, you do have a right triangle here by how D is defined. Uh, but it's not necessarily even like the right triangle. And if it was a right triangle, these would be squares. Um, so I don't really get why this would be true. But if I were to just see what you're talking about, Cook, and get to the right answer. Hey, DDM. Shout out to me. This first one is just the definition of moment of inertia for the center of mass. Um, this D is a constant with respect to dm? Yeah. And for whatever reason, this should disappear out, but I'm not sure why yet. R and RCM are both varying, just separating out the distance from P into two parts. Distance from the first axis to the second. R and RCM are both varying. It's just separating out the distance from P into two parts. The distance from the first axis to the second. The distance from the first axis to the general point. I don't get how like these aren't like it. You're taking the distance from P to a spot on the object, and you're, I guess, splitting it into two pieces. One of them we're just saying is distance D, but how do we know the other one is RCM? Like, that seems like it needs justification. Like, this would be very convenient, but how do you know they split up into pieces like this? Write the coordinates of a general point in the object as the sum of the coordinates of the CM plus the coordinates relative to the CM. Hey, Ved. R is a perpendicular distance from the P axis to a generic point. Hey, Rex. That emote is really funny. Or like, it's very cute. R is the perpendicular distance from the P axis to a generic point. Yeah. D is the perpendicular distance between the point CM and the P axis. RCM equals R minus D. I still don't understand that, and I have an even more stupid question. The this axis should be perpendicular to the page, right? Hey, Central. This axis is three-dimensionally perpendicular to the page, right? It's not in the same plane as the object. Hey, Lucas. That I'm trying to. Failing at it. It's physics. Let me look at your question, Ved. You have sine of arcsine. Are inverse sine and arcsine the same thing? I just like arcsine more. Uh, plus arc cosine x equals 1. Find x. Yeah, moment of inertia. Let me try with Ved's question here first, but I can look at yours after, Lucas. Middle of the yeast fermentation experiment, and I'm just not getting the results I expect. Not a happy bunny. I mean, yeast is hard to work with. Like it's you have to really control like the temperature and the humidity and stuff, right? Okay, cause yeah, I was getting confused in the chapter with whether the axes are actually perpendicular to the page or not. 'Cause I thought they started they gave some examples where that made no sense if they were perpendicular, but they didn't really say it. For this question in particular, I guess I would. Can we take the arcsine of each side? 6.2 out of 10. Your math is about derivatives. Hey, that's not bad. If we take the arcsine of each side, does something bad happen? Maybe a better way to think about it is if sine is equal to 1, then the inside of the sine better be um, equal to pi over 2, or some plus 2 pi plus 2 n pi of that. Other people looked at the easy bake yeast. I just got our dry active yeast, and you were going to think you'd done fucked up. Oh no. Is easy bake yeast the like? Is that what I think we might call that instant yeast here, which is the type that I use. I used to use the active dry, but it just seems so much harder to work with. So they're getting unreliable results using the easy bake stuff. Arcsine is inverse sine. It's the same thing. It's just that this notation with -1 is really potentially misleading. So I try to avoid using it. So now we can subtract the arcsine 1/5 over to the other side, I guess. Yeah, it's neither. Lucas. That's why it's confusing. And now we can take the cosine of each side, and we don't have to worry about plus 2. Oh, wait. Do we have to worry? We're going to miss out on solutions if we mess up something like this. And there's also a weird thing where cosine of arc cosine isn't always arc cosine of cosine. And I'm trying to remember which one is the trickier direction. I think this is the trickier one, and that's the one that we have. No, maybe we have the easier one. 7 streak, nice, Jed. Welsh cakes? No, I never heard of them. Cool Leuven today? And I mean, it's kind of, what is that? Um, University. Oh, nice. That's awesome. You spoken to me about Welsh cakes? I don't know. Is that recently? Um, Probably not. Okay. No, I don't remember you talking about them. I'm just gonna take cosine of each side and hope that we're okay. I'm getting. I don't remember how you think about it. X is equal to cosine pi over 2 minus arcsine 1/5 plus 2n pi. I think this is technically an answer where n is any integer you want. You can use some identity, or we can use some identities to change how the way it looks. We can use a cofunction identity to make it arcsine 1/5 minus 2n pi, and we can do a sum formula, sum 41. Can I get this off the top of my head? Sine of arcsine of 1/5 cosine 2n pi minus sine 2n pi cosine arcsine 1/5. Maybe in a different American, you're all the same to me. If sine of x equals sine of y, no, we can't say that, Ved. We can't say x equals y. The function has to be 1-to-1 is the term. And the issue with sine is that in particular is that it's periodic. So I could draw a horizontal line like here, and like at this point, if this is x and this is y, sine of these are the exact same value. They're at the same level on the graph, but the inputs are different. Like they would have, they're at two different x, or like, you know, they're two different values on the horizontal axis there. So no, you can't say that then. I'm trying to verify the sum identity for sine. Oh, I got it right. I'm popping off. X equals 1/5 is the solution by complementary angles. Oh, that's an identity. Yeah, right, Cook. Welsh cake can be either really good or the worst thing you'll eat. Depends how well it's made. Fair enough. There's a lot of things like that. Like cake in general can be really good or really bad. Oh, I'm missing out a bunch of chats here. Like a pretty damn good university as well. That's awesome, Lucas. I assume you're gonna try to apply to it then, right? I should redeem my beans for the Alex Jones clip. It'd be a little hard to set up for me. Michael Morpheus' way of saying it isn't finding your conversations memorable. Exactly that. Central's a very forgettable person. Casey Doodle, they look like pancake plus cookie. Oh, the Welsh cakes? We can add chocolate chips. We can add chocolate chips to anything we want. Mac and cheese. Draw rectangle with side length 1, diagonal 5. I'm nearly done with this, but the last statement reduces quite nicely. Yes, but no. Not this year yet, but next year probably. It's 42nd best university in the world. Nice. 42 is a good number. Oh yeah, Jed, you were a guest star on the Infinite series. Can you add chocolate chips to your Constitution? You can add chocolate chips to the Constitution. We need a national treasure too, where Nick Cage does that. Actually, wait, there probably already is a national treasure too. How many national treasures are there? Producing best means best Dutch-speaking university. I mean, yeah, 42nd globally is not a laughing matter. Cosine of 2 pi n. That's always 1, right? Yeah, that's always 1. Sine of 2 pi n is always 0. Oh, it's just x equals 1/5. Unless I'm missing a solution. It's possible there's more solutions that I accidentally missed with inverse functions. Book of Secrets. Oh, okay. Von Umbota? You have a question from real analysis? It's not my strongest suit, but I can definitely try my best. Feel free to put it there in chat, or you can put it in the Discord if a screenshot is easier. Okay, let me plug this. I'm saying the answer is just x equals 1/5, and there's no other solutions that I can find. I'm going to go to Wolfram Alpha, though, to verify. Because it's very easy to mess up something with inverse functions and miss out on a solution. Okay, Wolfram Alpha doesn't find any either. Okay, so yeah, I think that's how you do that one, then. Oh, Lucas, yeah, after you left, I figured out that your question isn't as hard as I thought it was. I just had too many things going on to be able to think about it for more than a few seconds. So yeah, you want to solve this equation for x? And so what I want to do here is divide each side by x. The thing is, whenever you divide each side by something, you should make sure it's not 0. So as long as x is not 0, we're allowed to do this step. But this does mean we need to think separately about x equals 0 off to the side here, which we can do in a second. Yeah, we'll do in a second. So that's what we do the division here. We get 2/3 is equal to, this is like an x to the 1, so it's 2/3 minus 1 is negative 1/3. And so now I'm going to write x to negative 1/3 as a fraction with a positive exponent, just to make the next step a little bit clearer to see, which is flipping each side. 3/2 equals x to the 1/3. And now the only thing left to do is to cube each side. So 3/2 cubed is 27/8 equals x. But we can't forget that we chopped off anything involving x equaling 0, so let's check that manually over here. And just plug in 0 for x. 2/3 times 0 equals 0 to the 2/3. That's just 0 equals 0. So I'd say there's two solutions here. X equals 0 and 27/8 equals x. Ved is asking what the parallaxis theorem is. I'm still understanding it for myself. I will just read this text that's here. That's a clip from the textbook that I got it from. I'm still trying to understand it for myself. Oh, that I think I see what you're saying, Cook, with the rectangle. Because you would make like a right triangle that goes like that. Actually, no, I mean, I don't think you even need a rectangle. I just think of a right triangle. If you have y over here, arcsine is that angle, arccosine is that angle, and the angles The other two angles in a right triangle should add up to 90. That to me, that's a way easier way of thinking about it. I equals mr squared. Yes. Then give you a question on a. I can give you a question on a math test I got right just to prove that I ain't stupid. I don't think you're stupid. If you want, you can post it, but I don't think you're stupid. Um, so yeah, Boda, unfortunately, like Discord has some really weird stuff where you have to do a couple steps for it'll let you post something. I wish I could get rid of them, but it's not easily done. Um, Once you do get past those and just like click through them though, feel free to post your question either in math homework help or math discussion, whichever one is easier. Question came in my exam. What caused electric shock, high current, or high potential difference? I think electric shock comes from high potential difference. Because the potential of your body is a lot lower than the potential of whatever is causing the shock. I think, at least. My body doesn't have much potential. It's because you've already realized it. You know, you're just already like super high up there. That's the optimistic take. Okay, so we got questions that came in just now from Lucas and from Umbota. Let's bring them both up and we'll start with whichever one looks quicker. I think that's a fair enough way of doing it, I hope. This one is Lucas's question. Oh God, I think okay. Lucas's question is going to be quicker. uh, okay, let's try and quickly. Can I figure out this thing without even Google Translate? Given a function, something, find A and B such that f, I'm betting is continuous at 1. Is f... Oh wait, is this continuous or differentiable? Okay, yeah. Uh, so in order to be differentiable, um, so if when you have a question like this and you need to be differentiable, you need two things to be true. These two functions should have the same value at x equals 1, and their derivatives should have the same value. That's what it means to be like differentiable here. Those are things that you need to check. So first off, let's get the continuous part of this, which is just dealing with the original function. we want a cube root x to equal root x plus b when x equals 1. So let's plug x equals 1 in. Oh, sorry, you're just showing me this for... Oh, you got question 2 wrong. Is they're asking, is f differentiable over r? I'm just gonna work through the problem anyway, but so from the continuous piece we get a equals 1 plus b when we plug in x equals 1. For the derivative piece we should actually find the derivatives. 1/3 a x to the minus 2/3 1/2 x to the minus 1/2 plus b. Am I actually wrong, Jed, or are you just beeping? Okay, so now I want the derivatives to be equal to each other at x equals 1. One-third a, 1 to the minus 2/3 is still just 1. And then 1 to the minus 1/2 is still just 1. So 1/2 plus b. Now it's a system of 2 equations and we solve for a and b. If I subtract them, I get 2/3 a is 1/2. A is 3/4. So b is 1/4. No. Minus 1/4? Yeah. And so, is f differentiable over r? And prove, Lucas says. Maybe that's the tune on. I wonder what counts as a proof for this. Oh my god, I don't know how math works. I did the derivative wrong. When you take the derivative, you get rid of the b. The b is a constant. Ugh. You just get that. A is 3/2. Which means that b is 1/2. No, square root of 1 is always equal to 1. The plus or minus only ever comes in if you start from x squared equals 1, and it only happens if you take the square root of each side of an equation. We're just given root x though. We didn't take the square root for ourselves. That's the Riemann Zeta hypothesis, Cytos. I'm pretty sure. Or the Riemann hypothesis. Yeah, I mean, that's the more rigorous way of saying it. For how square root is defined, yeah, that's the entire reason why this y equals root x looks like this. There's only one value. We could talk about y equals minus root x. That's the other piece of that parabola, but we don't have to worry about that here. For proving it's differentiable over r, I mean, I feel like we've already done the work. Like for 2, I would just say 3 over 2 cube root x is differentiable for x less than 1. Square root x plus 1/2 is differentiable for x greater than 1. And from part 1, we have shown that no worries, Jed. This one is better written with the kind of limit notation that Amit was using. That limit as x approaches a from the left. I'm going to the limit definition of a derivative. This might be a little bit overkill. But basically, I'm just saying limits from the left and right are equal to each other of the derivative. I guess, like, that's probably what I would write there. Nearest x squared is also called fx equals root x. Yeah, Lucas, it's because like the kind of general way of talking about functions that have weird behavior like that is you talk about functions that are one-to-one and onto. And a function that if it's one-to-one, does it need to be both, or is just one-to-one enough? I think just one-to-one is enough. If a function is one-to-one, then you have a clean inverse that's not like what you put there in chat. But x squared is not one-to-one, so it has a weird inverse. Yeah, that's fine. Okay, so let's consider oh my gosh, my brain is moving two different directions. Bota, let's consider your question here. Given a sequence of functions, f sub n maps 0 to 2 pi to r given by that disgusting thing, we have to prove the family is equicontinuous. Zach is very helpfully providing a theorem for us to use because I've never done this before. Never heard of equicontinuous. A and B are both differentiable over R. No, A and B are constants. You wouldn't really, or they're both like you wouldn't really. They're not variables. You wouldn't really. You wouldn't normally differentiate them. The sequence is right there. It's posted in the math homework help form as well if you want your own like copy of the problem. But I'll keep it up on the screen for a little bit longer. Bounded above by 1, if you understand correctly. Sequence of functions is uniformly bounded by 1. Is uniformly bounded if there's a number m such that f sub n of x is less than or equal to m for every function fn belonging to the sequence, and every x in AB. sequence is to be uniformly equicontinuous if for every epsilon greater than 0, there exists a delta greater than 0 such that so this is like a Cauchy sequence? Is that what this is an analog of? Why do we, and why is this, or how is this sentence related to this sentence? We never use M here, do we? You guys want to take a look at the solution? Yeah, I'm bored. I would like to just look at the solution and understand that. It's gonna be very hard for me to do this from scratch. It's slightly more than one? Okay. Same concept of uniform continuity, but for all n functions. It's a calculistic solution. Oh, I guess no. This isn't the similar idea as Cauchy. This is. I guess it is like continuity though, because you are shrinking the distance between x and y, and you wouldn't do that with Cauchy. Um, and so yeah, your question is actually about how to do the epsilon delta proof here. What is the alternative theorem or the alternative like statement? Sequence real value continuous functions defined on a close and bounded interval, AP of the real line. The sequence is uniformly bounded and uniformly equicontinuous. Oh. I think we need to go to this. I still don't understand why the why does it keep scrolling me up? I guess this is where they use the uniformly bounded piece, but this if then statement goes the wrong way. You need to start with uniformly equicontinuous. The converse, we would need to show that every subsequence f sub n itself has a uniformly convergent subsequence. Like that's something we could go after. Hmm. Maybe the idea of having this uniform bound would be helpful in doing this epsilon delta proof, though. Somewhere along the way. So what does this nightmare of an absolute value look like? If the sequence is uniformly bounded. Jerry Agor? I'm saying that right? Thank you for the follow. And that's not the Wikipedia page as far as I can tell. It seems like uniformly bounded isn't enough. But it's also I'm misreading it, or there's some other version of this out there that says that. I can see the fact that it's uniformly bounded help us prove that, but it doesn't seem like just the existence of it. As far as I can tell, is enough. The hell am I writing? Log of all that is always non-negative. Um, I agree with that. Yeah, Cytos. Yeah, it won't cancel, but it's definitely. I definitely agree. This is always a positive number or non-negative. Yeah. No, you can even say positive. You can't make this thing zero. I don't. No. Yes, you can. Never mind. Non-negative. Sorry. Mandelbulb. You'd render using it. I'd never heard of it. Interesting. Um. I assume we just have to be Chads in some way, and or I assume it's like a normal epsilon delta proof where you need to find a function for delta somehow, some way. I would be kind of I mean, it is a really complicated function. Bringing in series into a question like this feels sketchy though. Chad trigonometric and giga Chad things. The hypotheses of the theorem are satisfied by a uniformly bounded sequence of differentiable functions with uniformly bounded derivatives. This is probably what we want. Um, and I think that's where Zach was going with trying to get that bound. If we can show the derivatives are also uniformly bounded, I guess, and the original function. Academy of Useless Ideas. Thank you so much for the raid. Welcome in, everyone. How's your stream? I was lurking on you a bit, and I saw you were doing some like number theory type stuff with proofs with GCDs. We're working on an analysis question from Von Bota in chat. I'll put it up here on the screen. It's this top bit here. Hey, Femlux. For anyone who's here on my end, please do check out Academy of Useless Ideas. He has a cool stream where he just kind of talks about all sorts of pure math, some financial math, karaoke, all that good stuff. Yes, I have missed you with the fiery intensity of 1,000 white suns. I very much so have. Oops, I put my desk. But yeah, working on this, we have a sequence of functions, and the test has proved that they're equicontinuous, which is a new term for me. So we're just doing some poking around in Wikipedia to see how we can try to do this. You might be learning about them this time next week. That's true. Next Saturday will be the first reading group on general relativity. So that's something to be excited for. Although I'm pretty sure next week we're going to be talking about spherical geometry, but the thousands of white suns, I'm sure we will talk about at some point. Um, oh, wait, this is uniformly equicontinuous. Ooh, 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 ooh. That's uniform. The question is just equicontinuous. Um, oh, disgusting. Uh, what is all this? Okay, this is not whatever this is. It's not what I want. Yeah, the reading group I'm planning to be start an hour ago and last for 2 hours on Saturdays. Um, I'm always of the mind that if you're a math streamer, you should stream when you want and don't worry about like conflicting times. Like we should all just stream when we feel like it and when we do have time because we all have lives and other things that we could be doing. But if you do want to tune in, that's always like a welcome thing too. So I see Megalomorph just posted in the Discord. Megalomorph can't stay in stream. Okay. Four's fine. Okay. Yeah, it's always nice if we can like line things up in that way, but um I think the priority should be people like taking care of themselves. Hey Viv. Uh Nothing much with me, just working on this analysis. How about you? It's been good to see you around more. You're like low key, you're one of the more OG people around here. How long have you been? March 23, 2023 is the date that you followed. That's like maybe 2 months after I started streaming. It's kind of impressive. Um, Differentiable functions. So should we go to Desmos to look at how this thing behaves with ends? That might be. I kind of want to do that. It's not very mathy of me to just not figure it out by hand, but I think I could figure it out by hand. But I want to look at Desmos. Yeah, because I can see we can bound cosine by one pretty easily, and log is uniformly increasing a lot. What a cool function. For n equals one. Um, just take 10. Is this starting from n equals 0? No, it can't. Yeah, it could be at n equals 0. Oh, they don't specify it, but it's fine. Um, yeah, 0. It's like log is monotonically increasing. So as long as we can find the maximum of the inside, we could bound this log as well. I just want to see visually what this thing looks like, though. We only care about 0 to 2 pi. Whoa! What? What is this? What a crazy function. How? What the hell? This the period or the frequency of this thing is off the charts. I guess that's the end to the end at work. It's titration for you. It starts off pretty normal. But by the time we hit even like 3, it gets kind of wacky. 4 is like, ooh. Okay. Anyway, if we want to bound it just the original by hand, um, how can I arrange this? Let's put the Wikipedia stuff upstairs. in the attic. So I can forget about it for now. Just like, well, I don't have an attic, but I do have some boxes in the back of my closet that I don't feel like dealing with. Okay, so I think the angle that we're taking is trying to go after this, which is uniformly bounding the derivatives. Which it's going to be interesting to try to prove that for all derivatives, but that's a problem for me in about 10 minutes. So cosine n plus x is less than or equal to 1. That's the easy bound. Log of this, we can bound this by maximizing the inside over 0 to 2 pi. So take the derivative, I guess. That's kind of an annoying derivative. It's with respect to x, which makes it easier, though. If it was with respect to n, I would just quit. Cosine n to the n x, because quitters always win. 2 n to the n or root n plus 2. I guess we would set that equal to 0. Okay, so... Oh wait, n equals 0 doesn't make sense. Because you have 0 to the 0 is indeterminate. This sequence starts at 1. I wonder how Desmos handled the 0 to the 0, because it didn't give me an error. So this thing hits a maximum when n to the n from sine equals 0 at multiples of pi. N is a bad letter. K pi. Or n to the n equals k pi over 2. But that actually covers all our cases. Or like these cases also cover these cases, right? Oh, you know what? I didn't even set that up right. This would have to be an odd number, but looking at these two things together, let's just take k pi over 2 and all our bases are covered. So we have to check 0. Oh, that's... Oh. It's not just one answer. And it depends on n. That's not so simple. I was hoping we wouldn't have so many options. We'd have to check 0, pi over 2, pi, 3 pi over 2, 2 pi. And which one is the right answer depends what number derivative we're on also. Or, sorry, what number n. But later it'll also matter what derivative we're on. Hey, Thanish, Don does stuff. That sucks. I was hoping for a cleaner answer here. Is the world where log is base 10 or log is base e? I have no clue. I'm betting since it's an analysis class, it's base e. I don't imagine it's all that important, though. Base e? Okay. Okay, here's what we can say. We only care about n equals 1 because sine is bounded, sine squared is bounded between 0 and 1. So as n increases, our denominator is only getting bigger. This thing is going to be at its greatest when n equals 1. Um, Second term inside the log will be positive and less than or equal to 1. No, it's greater than or equal to 1. Oh wait, maybe that's what, no. Uh oh wait, the second term inside, yes. Okay, no, I agree with that. This thing, I agree, it's positive and less than 1. And so the input of the log is always slightly more than 1. Um so I studied I have a bachelor's of applied math. I went to Hawaii Pacific University. I'll just say it, I don't really care. If you're interested in math streams in general, though, I would definitely like. I'm not the only one who does this. Everyone in that list does math help in some way. We were just rated before by a person who isn't on that list, Academy of Useless Ideas. So there's even more streamers than are on that list. There's Academy of Useless Ideas. There's also Fred. And there's even more than these, but I'll stop there. There's a whole niche of math streams out there. Um, so we had like Itsutue Pai who was talking about this question earlier. Or you know, he was like just here in chat, and you were talking with him. He also streams, and he's much better with analysis than I am. So he was actually just streaming a couple of hours ago. Um, yeah, I mean, welcome in. I think we have a really cool community here. Um, and so anytime I see a new person, um, I try to let them know that like this niche exists, and even if like my stream isn't the perfect fit for you, like one of these streams will be. Like if you're interested in math, there's someone out there who's going to be doing a stream that you would like. Um, but yeah, I'm gonna say I think we only care about n equals 1 for the reasons I was saying before. Like this thing is only getting smaller as n increases. So if we just let n equals 1, uh, my final projects for Excel, Word, and PowerPoint, I'm basically almost done. Nice, famished. Yeah, it feels like there's like a trickle, like people kind of like trickle in as they think to search math on Twitch. And so, um, and it's kind of cool where you can see someone like type in someone's chat for the first time, and then I'll see him in someone else's chat, like getting to know that streamer, and then in another person's chat, and they just kind of like slowly become a part of the community too. It's a really awesome thing to see. Um, why did I drop the X? Okay, so X equals K pi over 2. So let's check. Do we just plug it in? I guess we do. Um, I guess I'm making a chart. I'm hoping that the process will be like I'm spending a lot of time just looking at f sub n and trying to bound that. I'm hoping the process for bounding the derivatives is going to be easier. uh, f sub 1 of x. So we'll check 0 first. We're gonna get 1 from the cosine. No, we're not. We're getting cosine of 1, whatever the hell that is. Um, Dude, this is terrible. You know what? I'm going back to Desmos. I don't want to do this by hand. I wonder how important this actually is. Okay, the maximum is that 1.15. 5 point that is that 3 pi over 2? Yeah, and I always like having the solution around. That's not 3 pi over 2. That's concerning. Oh, I know why. Oh yeah, I'm doing the wrong thing. I'm not maximizing F1. I'm maximizing the inside. And actually, if we just know that it's sine squared, we don't need to do all that much work. Right? Sine squared x over root 3. We should just be able to figure this out, right? It'll have a maximum. It equals 1. Pi over 2, 3 pi over 2. It doesn't matter which one we choose. It will matter when we get around to cosine, right? Yeah, sure. I know like a tiny bit of Spanish, but I'll be much better off with English. Yeah. Um, and the Discord server has a bot that can render LaTeX code. So you can just send the LaTeX just in dollar signs in a normal Discord message, and it'll render it for you. Like if I do that, the bot actually like renders it. So oh, you know what? I don't get to shout him out enough, but if you're more comfortable in Spanish, Alejandro is a Spanish language math streamer. He might not stream at the best time for you. Am I spelling his name right? Yes, but you might also like it. His stream. Oh, wow. The bot actually knew what to do with your. Okay, nice. That's kind of awesome. You sent an entire like LaTeX document, and the bot just like did it. I haven't seen someone do it that full on. Um, Let me bring this up. Uh oh, this might not be. Um, Honestly, like um, I assume the length it doesn't seem that bad compared to what we'd have to do to bound the derivatives. Yeah, and there's no obligation to actually like go through and look at everyone. I just get enthusiastic about shouting people out, I guess. But I know it's a lot, and like you probably most people like don't want to go through and hit follow on a bunch of like random streams, but um, when someone mentions that they like speak Spanish, I try in order to shout him out too. Okay, so they split up using triangle inequality. That seems like a good idea. Delta 1 equals epsilon over 2. Using trig identities, this is true? Why is that true? The original proof goes deeper? Oh, okay, okay. And justifies that? Okay. Yeah. I guess that's why this looks short. I guess you could do would our product to sum or sum to product rather help you there? Maybe. But okay, for now I'm just gonna have to believe that. To bound the log term. Um for large n, the root dominates. Yep. And I guess they're using the I mean sine squared is never -1. So the choice of 2 seems a little like random, but it doesn't hurt. 2 is definitely always more than that, I guess. For small n, really? Yeah, I would need to read more about that. Once again, I want to check this text. Sorry, I'm almost done sending this. Okay. Couple images from the original proof. Oh, I mean, you can just put them in the same thread as you originally made too, just to keep everything in one spot. Um, and so your actual question here is about how they're getting delta. Okay. Trigonometry for difference of cosines. Okay, yeah, so you do the sum of the product. Maybe want to see my thought process. Um, yeah, I mean that part I feel bad about because I probably just can't do this problem on my own. My analysis isn't quite that good. Uh, so I guess here they're making the claim that sine of x minus y over 2 is, or like, I guess the sine of this sine term is less than 1, or sine of, what is that? How are we going from here to here? I guess it's just using the property that sine is less than or equal to 1 or negative 1. So it's only ever going to reduce your, and I assume we're just choosing the x minus y bit because it's going to be helpful because delta bounds x minus y. Um, okay. Sounds good. I'm sorry I couldn't get you a better answer in time. Um, but yeah, I look forward to hopefully seeing you again. I'm going to consolidate some of the things you posted in Discord into the thread that you originally made and delete some of the other posts just to keep things clean. But yeah, thank you so much for the follow and for coming by. Um, doo, doo, doo. Just give me 1 second as I copy some images. Then I'm going to delete these other forum posts. Okay. So for now, I guess I'm just going to drop it because this one, I'm sure I can understand what's happening, but it's hard. I feel like I don't have the analysis skill to like prove this on my own. Um, you know, and let me post this Wikipedia page. Okay. So at this point, if someone else asks a question and I forgot about it, please let me know. It wasn't intentional. Absent that, I'm gonna go back to studying mechanics. That's what I was starting the stream with. Okay, so I was working on the parallel axis theorem. Dr. Cook said to do this, which I still don't understand, and then plug it into the integral definition. I assume either one would work. And somehow this thing would pop out. Yeah, Fenlox, I just stopped working on chapter 6. I'm not done with chapter 6, but I'm I'm just skipping the rest of it. And I'm gonna do whatever I can with chapter 7 today, and then I'm gonna move straight forward to chapter 8. I just want to at least plow through the reading in a couple problems if I can for like the rotational stuff in the mechanics book. So I figure it's gonna be important in relativity. I assume it is. Yeah, I'm nervous about it too. Especially with rotational stuff, I just kind of don't get it. It's just weird. Write the coordinates of a general point in the object, which is something like on the plane of this, or like a general point could be like that right there or that right there, as the sum of the coordinates of the CM plus the distance relative to the CM. I Why? Like, how is this not just a triangle? Like the distance that we're after is from P to an arbitrary point on this thing. This distance is clearly not equal to the perpendicular distance between the center of mass and the point, plus the distance from the point to the center of mass. Like, you could probably make a triangle somewhere out of this. But I really don't get why. That will be it. I could just work on this part of actually, if I just accept it, it's true. Why this should be equal to that. This ICM comes from the first integral. That's just the definition. Well, I mean, yeah, this part is almost there. I have no clue why the hell this thing is true. I can't justify the first step in my proof. um, and so I know this thing is supposed to be 0 for some reason, and that this thing gives me the MD squared. I don't know why this is 0, though. Or I assume that's what I'm supposed to get here. I was getting tripped up with that because the moment of inertia, it's a scalar. At first, I was trying to think about vectors, but they're just scalars. I guess we could have a negative distance. That's the only way I can think of that the case that I drew could work. If I were to look at like that point, then I can definitely see. Well, even then, not necessarily because D is defined in such a weird way, but I don't like how this is drawn. If this is a planar object, the perpendicular distance from the CM axis to the P axis should also lie in the same plane. But this is drawn in a way that implies that it isn't, right? Also, I really don't understand this. What's the most difficult problem someone has ever made you attempt on stream relative to the difficulty of the content it relied on? Stochastic Turtle, thank you for the follow. It's a cool name. Oh no, this is not the hardest problem. I just don't understand physics. The Collatz conjecture. Someone accidentally gave me a disguised version of that. Someone recently gave me a competition integral that didn't even use any crazy ideas like Feynman or anything. It was mostly like stuff you've learned in Calc 2, just really complicated and a lot of subs. I think I used King's property once, but King's property isn't the worst, I don't think. Uh, his professor gave him or gave the class a question. That's the disguised Collatz conjecture, and said, if anyone solves this question, I will quit my job. And so he gave it to me to see what I thought, and and after I played around with it, I realized that it's just the Collatz conjecture. All right, see you soon, fun bucks. Hey again, Lucas. It's possible to pack every unique rectangle with width 1 over k and length 1 over k plus 1, where k greater than or equal to 1, into a unit square. Maybe, I don't know. Cytos is that some like is that a really hard problem? It sounds like it. If you want, I need you to explain you Taylor series. Why are you doing Taylor series already? I can talk about them a bit. So Catholic Turtle, not say one day I want to do something similar to this. I mean, online tutoring. So, oh, hey, that's awesome. Um, if you're interested in streaming like this, please feel free to ask me any questions you might have, either on stream or even in like a Discord message. If you're interested in other people who also do math streams, I'm not the one out there who does this. So there's a whole list of people to like get you started. If you're interested in seeing like what other people's like styles of streams are. But yeah, if you're interested in doing this, like I would love to support you in doing that. You're just curious. You don't know what a factorial is? Okay, let me explain to you what a factorial is first, because those are relatively quick to understand. A factorial means like four. Oh, you know what it is? Okay. Oh, but okay, you just haven't learned in the class, but you know what it is separately. Okay. It's time to chill for Paul. Do, 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 do. Yeah, no worries, Turtle. Um, Actually, let me add in one person too. We just recently started up streaming, Fred as well. While I'm at it. Organize for one day, core culture immersion, intended each person teams play one match against each other. Okay, Siren's about to put a question. I'm gonna talk about the Taylor series first. Properties letter I summation index is a cursed motherfucker. Yeah, this curse is using E. I like I. I mean, I minored in computer science, so I'm used to using I as an index. Okay, so Lucas, a Taylor series is how do you even start with it? If you're given any function, any differentiable function, okay, you need to be able to take the derivative of the function as many times as you want. Like it needs to have a defined derivative. Um, if that's true, and probably continuous. If that's true, you can make what's called a Taylor series for that function. And a Taylor series is basically just a polynomial that goes on forever. So you can get it's probably better to look at examples first. So like e to the x, it's just equal to this polynomial. It goes on forever, but like as you can show that e to the x is equal to 1 plus x squared over 2 plus x cubed over 3, or over 3 factorial. It's a really neat way of representing different types of functions because polynomials have really nice properties. And if you were to compact this into like one summation formula, it would look like this thing down here. Polynomials, you've seen them before, you just don't know that term then, maybe. Or maybe you've learned the term in Dutch. A polynomial, like an example, polynomial. An example of a polynomial is like x squared plus 2x plus 1. It's just powers of x's and like coefficients. So it could also be x to the like a half x to the fifth plus 4x cubed minus 2x plus 5. Veal term? Okay, maybe. Yeah. And so if you're okay with the idea of a polynomial going on forever and having like 1 plus, well, 1 plus x plus a half x plus, a half x squared plus a 6x cubed plus a 24th x to the 4th plus off to infinity, that's what a Taylor series is. It doesn't have to be infinite technically, it just almost always is. And so let me show you visually what this looks like. Yes, once you let it go to infinity, it perfectly gives you E. They're really helpful because you could use just say the first like 5 terms and get a decent approximation. So here's e to the x, the thing that we're trying to like look at. And let's do the power series for e to the x. N equals 0 to some constant a of x to the n over n factorial, add a slider for a. This will go, a will go from 1 to, I'll set a manually. So n is just the index. So yes, 0 factorial is 1. So do you know how this summation works? Like with the capital sigma? Okay, then let me start with that. If you have the sum from n equals 0 to 5 of, let's say, n squared, what you do is you start with n equaling 0, plug it into the inside, so we get 0 squared, and then you do plus, now you let n equals 1 and plug that in, so 1 squared, plus, this capital sigma means summation, so you do pluses but between each n value. Now n equals 2, yeah, and so you do it up until 5. And the magic of a Taylor series is that instead of a finite number, you just put infinity there. So it is difficult, but you kind of need it. It's necessary for the exact thing that we're looking at now, to be honest. And so that's what's happening here, basically. And x is just, it's still a variable, and is the thing that we're like plugging things into. A is however far we're going to let our sum be. It should be infinity, but it's really interesting to see, instead of letting it go out to infinity, it's interesting to see what it looks like as you just let it get higher and higher. Like if you see the progression. You see why people like doing theoretical work because the practical stuff is poopy. So if a equals 1, we just have a line. And you can think of this line as approximating e to the x. Now, it's clearly not a very good approximation. Like, it's only a very good approximation really close to x equals 0. But around there, it's not bad. The farther away we go, though, it becomes a pretty terrible approximation. Now let's if we include one more term, oh my god, just a equals 2, we get a parabola, and it's still a pretty terrible approximation for farther away, but it's an even better approximation around 0 now. Like if we look only around here, like That's the difference. Like it follows for like a little longer before it shoots off and does its own thing. Yes? Okay, cool. We let now if go a equals 3, that trend continues. It's even better. Exactly. The higher a goes, the closer it gets. So already at 3, like this isn't bad. 4, 5, 6. See, this is pretty freaking good now. 7. Like the right side is nearly like taken care of. The left side, you need a lot more terms for that. But if I just go straight to like 1,000, it looks really good. It's still going to shoot off somewhere like once you get far enough to the right or left. But this is not bad. The way you find it, is with this formula, unfortunately. I guess we were using this formula, which is a little bit simpler. It's a Taylor series, a derivative on meth. Yeah, basically. Let me go to journal++. If the function that we're looking at is e to the x, what this, like a Taylor series always looks like x to the n times something. Or like, I guess like, we always know the n factorial piece. We always know the x to the n piece. The only thing we really have to find is this thing. This is the nth derivative of f evaluated at 0. So f of 0, like the first thing we get when n equals 0. Oh. Saram, I thought I told you, but I'm talking about this first, and I'll look at your question. Okay, sorry about that, Lucas. You're not supposed to get ads in the middle of the stream. Or I don't want people to get ads in the middle of the stream, or ever, but I can't control that. You have to leave now? All right, Turtle. Thanks for popping in, and feel free to reach out if you ever need like have any like questions about streaming. Hope you have a good day. Okay, so let me repeat myself. So this formula tells us, it already tells us almost everything we need to know about the Taylor series. Like the x to the n piece is fine, the n factorial piece is fine, the summation is fine. The only thing we need to find are these things. These are the nth derivative of f after you plug in 0. Or, you know, you find the derivative of f and then plug in 0. It is the better way of saying that. So when n equals 0, you get the 0th derivative, which is just the original function. So you just take the original function and plug in 0. So that's just 1. When n equals 1, it's the first derivative of f, so just f prime. So the derivative of e to the x is just e to the x, and now we found the derivative, we plug in 0. 1. So I hope you can see the pattern here, where when n equals 2, we do the second derivative, that's still e to the x, And so we're always going to be plugging 0 into e to the x, because just e to the x is a really like simple example to use here. Normally it's something more complicated. A Gmail? No, I don't have a Gmail for like sending questions. You can put it in the Discord, but that's the closest thing. And so kind of the pattern here, it's just always one. Like sometimes like actually usually you have to find some sort of pattern in whatever you get here and write it in terms of n. But since I chose a simple example here, it's always just one. So we can take this formula here and say that e to the x is equal to the sum from n equals 0 to infinity. The n factorial piece is fine, the x to the n is fine. And then for this piece here, we're saying it's just always one. But like, I could also just write this as x to the n over n factorial, and that's the exact thing we were using before. So if you want to find a Taylor series, the only thing you really need to do is figure out a pattern for these derivatives and put it in terms of n. Yahoo Mail's where it's at. True. And so you can also do it, you don't have to do it at 0. There's a different version if you want to do it around some other point, but 0 is a little bit simpler. Yeah, that's a basic idea of what a Taylor series is. Wait, Siren, is that a complete question? I think your question got cut off, Siren. Yeah, so they can really grill you on these things. I'm talking about one of the easiest examples here for a Taylor series. Once you actually learn about it in a class, they're gonna throw some harder things at you. But that's kind of like the idea of it. What's the radius of convergence? How do we determine it? I don't think Lucas has learned about power series yet. I think that's gonna be a little bit too difficult to explain. At least, I mean, if you're asking me syntax and you want to hear about it, I can definitely talk about it. You're asking? Okay. Sorry, yeah, I wasn't sure if you were just trying to ask a leading question or if you're actually like asking it for yourself. A power series is okay. The example I originally showed you, like this here. Oh no, freaking. This summation here is just a series. It only involves like n. It becomes a power series when you start sticking variables in this. Like if I stick an x in there, it's now a power series. And you, to answer the question that syntax is asking, you need some more general knowledge about power series. And about series in general. That's so the next piece I'm about to explain for syntax error is a little bit. It takes too much background for me to easily explain to someone who hasn't hardly worked with series before. You did McLaurin series before uni, but not rigorously. Yeah, I never learned them rigorously until Zach's infinite series class. To be honest. And yeah, syntax error kind of I mean, the power series have to be x to the n. I think it. Ooh. Wait. I'm just gonna make sounds until I have Paul tell me. Okay, yeah. A power series is a summation, an infinite summation. It's an infinite sum of some like sequence of numbers. I'm usually using the letter A. A is just some sequence times x to the n, or potentially x minus some constant to the n. That's the kind of general version of power series. It's basically, you could think of like an example of the a to the n as n squared, just like a general version of that n squared bit. And so a power series is like a normal series, but you insert an x to the n. And the x is a variable and you evaluate at different x's. Yeah, you're right, syntax. If it was just x, you could factor it out. It wouldn't be a power series if it was just x. And so you find the radius of convergence using the most common way is the ratio test. Let's take Paul's example here. Oh, no. Oh, I did the wrong thing. Okay, so if you are given a power series, so this is a more complicated example of a power series, but it's still a power series. This isn't necessarily a Taylor series. There might be some function this represents. I guess there probably has to be. But we can look at just the series part and not worry about what function it represents. The series that we looked at for e to the x is good for any value of x, as long as you let it go to infinity. There's some series that even if you let them go to infinity, they're not always good for every x. And you describe the range of x values where it's valid as a radius of convergence. And so we can find the radius of convergence by doing the ratio test. So as a reminder on the ratio test, how is normally expressed? You take, the ratio test says that a series converges if the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n is less than 1. If it's greater than 1, it diverges. If it's equal to 1, it's inconclusive. Try something else. Is the radius literally radius of a circle in a complex plane? Probably. I haven't learned about complex series. At least if you only talk about real numbers, you can let's say this is 3. You could a one-dimensional circle is basically just an interval. So like you could have a circle of radius 1. That's just that point and that point in one dimension. And so that's why it's still a radius. I bet in the complex plane you get a circle because it's two-dimensional. But it's still valid to call it a radius even in one dimension. It's a pretty lame circle. It's only 2 points. It still is a circle though, in that sense. So yeah, we can take the ratio test and apply it to a power series and figure out what values of x it's valid for. So let's do limit as n goes to infinity of -1 to the n plus 1. So for the a sub n plus 1 piece, we take the entire thing and plug in n plus 1. And then the a sub n is just the original power series. Okay. So this is a pretty crazy limit. They pretty much always simplify down pretty nicely though. First things first. What's the first things first? We have absolute value bars. Let's just get rid of the negatives there. Because that yeah, exactly. Syntax error. So we still have to be careful of the absolute value when it comes to the x's. But we can release like this entire piece from the absolute values. N plus 1 over 4 to the n plus 1. And then I'm going to flip this and multiply it. Sorry, I guess I'm going to flip this and multiply it. And so now for the x plus 3 bits, x can be a negative number, so we still need to be careful with the absolute value. We do get the n canceling with the n, so we just end up with an x plus 3. And that cannot escape the absolute value bars. It needs to stay inside. But there's a bit of good news where this doesn't involve n. It can just come in front of the limit because the limit doesn't care about it. It doesn't involve n. So x plus 3 can come in front. Limit as n goes to infinity. The 4 to the n cancel the 4 to the n. Still have a 4 left over on the bottom. But this thing cleans up to be n plus 1 over 4n. And so the limit of that as n goes to infinity. I'm running out of room. Let me bring this on to the next page. This limit evaluates to 1/4. But this is as simple as we can make this thing. But now it's kind of like, well, what the hell? Like, where does this thing converge? That's when we need to remember the conditions for the ratio test. If our limit is less than 1, we're in business. So let's take the thing we got and evaluate it when it's less than 1. Like, what x will give us this? So we can start by multiplying each side of that inequality by 4. The absolute value of x plus 3 is less than 4. And now we can drop the absolute value bar if we put a -4 on the left side. And now we can subtract 3 from every side. And so it's easier to see from this stage, but from here, we can just say the radius of convergence is 4. Because that's like half the width of the interval. Sorry, the radius of convergence is 4 because you can just like see the 4 there. Or you can think of it as this interval has width 8, and half of 8 is 4. Taking it this far helps you find the interval of convergence. Exactly, yeah. And so if the ratio test equals 1, it's inconclusive. And these cases are when it equals 1. So we have to manually plug those in and check them separately. That's a really common thing for calculus students to forget. But you would take -7 and 1, plug them back in right there, and check if that series converges or diverges. And if it converges, you would include it. If it diverges, you would not include it. And so we can actually go through and do that too, I guess. Or if you're comfortable with it, I'll start to do it, but if you're like comfortable with it, then I'll skip it. So if we let x equal -7, n equals 1 to infinity, -1 to the n, 4 to the n. You think you got it? Okay. Then I'll leave it there. Yeah, at least in the ways that I've seen it, they would normally want you to write it in like interval notations, like -7, 1. And you probably use different notation for, I guess you might use like that notation for an open interval. But it could also be like half open, or it could also be closed. Like you have a lot of like possibilities to like write it, but yeah. Yeah. Oh, Paul's online notes. I love this site. It's my favorite site for everything calculus. It's absolutely free. And they have a like the site is bad for anything that's, if you want the theoretical idea of things, it's not good. It does give you the intuition though, and it kind of gives you the minimum that you need to know to get through a calculus class. So if you want theory, it's not the best, but I like it for students who are just trying to get through a calculus class. And the examples are really well chosen, and the solutions are really well written out. And Emma de Blame, I saw your exercise up there. Might take a look at it in a second here. Yeah, okay, so that's where I don't know, because like I've definitely seen that notation. French people use that notation, Jasu. I don't know what countries in Europe do what though, so I try to play it safe. Yeah, I realized it was already shill o'clock. It sure is. I'm Paul's online notes shill. Hey Storm, I'm just at the end of talking about what a Taylor series is and how you find the radius of convergence. We're about to switch gears into another problem that I'm trying to figure out. For the parentheses to brackets, but okay, yeah, fair. Okay, so let's look at Amidablam's exercise, because I think we have a little pause here. We got taught the right one and the French one. That's hilarious. You like some talking? You drink a large milkshake today? Oh my god, you're a ticking time bomb, syntax. The exercise misses the hypothesis. You think f of 0 equals 0 is also needed. Left and right cosets? Oh, I never learned those. I've heard the term. I don't know what they are though. I don't know how you do this. It's kind of interesting if this is true. I don't know where you even begin with something like this though. Yes, Storm. Oh, the Taylor expansion? Oh. And I assume that that's why we're giving it analytic. Oh, and that's why you would need f of 0 equals 0, I guess. Clear version is in the Discord. Cooking a burger in the oven? No, that sounds unhinged. You have 0 step after? Oh, okay. I've done bacon in the oven. That's delicious. A burger sounds not good. Here's our saying, try to factor out an x from here. Oh, wait, okay, yeah, this is a... We should look at... Let me delete this, because this is a different problem. A function f is odd and analytic if and only if it can be expressed in the form xg of x for x is even in analytic. Never heard of it? You have heard of it, just never tried it myself. Interesting. No, yeah, I haven't. Okay, given the... Okay, this odd piece is significant. I see the exact idea now. Um... Since f is odd, or f is analytic and odd, if f is an odd function, its Taylor series has to be odd also. A sub 2n plus 1 x to the 2n plus 1, right? I mean, is that a good way of saying it? It can be just a sub n. The x to the 2n plus 1 part is the important part. Yeah, okay, this is quick now, because you take one of the x's out of the series. A sub n x to the n, let g of x equal the summation piece. Sorry, 2n. I dropped the 2. G of x, just from looking at the series, is even and analytic because of that representation. F of x equals 1 is analytic. Oh, you have to... Wow, that's why you need f of 0 equals 0? Hmm. Fx equals 1 isn't odd. True. Yeah. F0 equals 0 is useful in order to factorize by x. I'm not sure why. Oh, I see. Yeah, so as you can't factor the x out, I guess. And you could reverse this argument to prove the other direction of the if and only if. Okay. Oh, okay. So once we force it to be odd, then we don't need storms condition. Oh no, or do we still need it? Because yeah, you don't want there to be a constant term in this series, right? You want them all to have x in order to take the x out. Otherwise, things get messy. Oh my god, that's a good scrunch. I just like curled my like legs up into my chair. Find a function which you can differentiate infinitely many times, but is not analytic. Okay, what is the definition of analytic? I thought that is that not the definition of it, analytic? No, analytic is just it can be locally given by a convergent power series. Tertar is saying there's a famous example of that e to the minus 1 over x squared, like the Gaussian distribution. Differentiate infinitely many times, but is not analytic. It's not Gaussian? Oh, yeah, that's e to the minus x squared. You're right. A Taylor series does not need not necessarily converge to f of x, even if f of x is infinitely differentiable. Hmm. Differentiate how many times, but not analytic. The idea here is that a Taylor series. Oh yeah, I already read that. The necessary condition that f of x is complex differentiable in the radius of convergence. Big distinction between complex differentiable and just differentiable. Oh, okay. I need to get more into complex variables. Because I really don't know enough about them. So f of 0 equals 0 because it's analytic and therefore continuous. Oh, yeah, an odd function has to go through 0. Or it has to have the point 0, 0, right? That makes sense. Or, ooh. 1 over x. That's odd. But it's not analytic, probably. Okay, fair. Yeah, I don't know. 1 over 1 plus x squared is differentiable for real x, but not at x equals I, so it's only analytic within the region r equals 1. Oh. Can try to prove the function is not analytic, it's an induction. Yeah, Storm, I realized that after I said that with the 1 over x example. How would you prove it's not? Like, would you let it be equal to power series and find a contradiction, or like what? Show that f of x is infinitely differentiable for all x. I mean, so should we attempt to find the Taylor series for it? Thanks for the follow, Cytos. I guess we can do it about 0. Oh, well, that's kind of a problem. You're saying f of 0 equals 0. Okay, I guess we manually define that. If you do induction in the nth order, prove it's not analytic. My cam is frozen? It seems okay to me. I might have just been very still. Or maybe it froze for a second. It's fine for you? Okay. You move. You are alive. This is... Why are we doing it about 0? I feel like we're just constantly getting issues if we try to do it about 0. I'm alive. Yeah. Guys, be careful. If you give me too many analysis problems, I might die. These derivatives get really annoying really quickly. Planes are not alive because they don't move. Moment at 0 is finite. Is that finite? Oh yeah, I guess they do move just really slowly if they're growing. Like this limit? That seems... Is this likely or unlikely? I can't tell. We have e to a very large negative number, which is going to 0 really fast. It's going to 0 faster than x cubed. Is that the idea? L'Hopital's doesn't really work on that, I don't think. L'Hopital's just makes the problem worse, I feel like. L'Hopital's doesn't apply, even. Never mind. Oh, man. Show that XE? Zero plus. Um, I guess that's infinity times 0, so we can L'Hopital's that. And L'Hopital's is potentially actually helpful. I hope. You don't like L'Hopital's? It's not actually helpful. I don't think. You look at a series, I guess. What? That looks stupid, though. Maybe that is what we... Is that what we want? I guess that goes to positive infinity, right? I'm thinking of it as basically 1 over x squared. Or like each of these um each of these x's individually are going to positive infinity, right? So I think we can justify that. It's always infinity plus infinity plus infinity plus infinity. There's no minus infinities. I guess that's how you can do it. Oh, you bound it from below. Really? Is that true? E to the 1 over... I need to... I can see how that's like using the definition of E in some way. That doesn't seem true, though. Oh, wait, no. Yeah, it does seem true. Here's our saying the Laurent series of E to the 1 over x squared. I haven't learned about those, to be honest. Once I get made with the problem earlier, they assumed f of 0 equals 0 without adequate justification. I'm a massive pedant. Yeah, I said it verbally that an odd function has to pass through the origin, but I didn't. I guess I could have justified that part more. You're right. Oh, you're thinking of the series for e to the x. Okay. Yeah, fair enough, Storm. I was thinking of the limit definition. Sure, that kind of looks like 2. Okay, I guess it's... I mean, isn't the entire... Oh, no, we're talking about e to the positive 1 over x squared. The point of the exercise is e of the to the negative 1 over x squared. I mean, well, I don't understand why we're doing this in the first place, though. Oh, I guess I did write the series in a way there where there is no constant term. Because you can put 1 o... Oh, okay, yeah. Uh, okay. And so that helps answer the question of how to evaluate f prime x at 0? Or like not evaluate it, but what how we should define it, which is just 0, 1 over infinity. That was the point of doing this. Are we just gonna always get 0 for these? That's what it seems like. Because I guess we get a quotient rule, but I should prove it by induction that the nth derivative. I mean, I need to find an expression. It's going to be the quotient rule though to do an arbitrary derivative. Do not need to commute the nth derivative or compute the nth derivative. There's a fine way to do it. I mean, I can see intuitively, it's always going to be some version of that divided by that. Or like, the e to the minus 1 over x squared divided by some power of x, and that's going to behave the exact same way. But actually doing that calculation sounds kind of terrible. Okay, yeah, and so that's the more formal way of saying what I just said. Um, um, I can see why it's going to work because, like, if you were to do instead of quotient rule, I guess you can keep it simpler and do a product rule. But you can always factor that thing out from whatever product rule you do. It's cool that it's not analytic. Else, when the series was obtained that the function is constantly equal to 0. Yeah. So that is a neat result. I don't think I want to go through and do that entire proof. But that is interesting that you can take as many derivatives of this function as you want. But if you try to make a power series with it, you'll just always get 0. I mean, it's a little bit weird where it's not actually defined at 0. I guess it's a removable discontinuity, though, so it shouldn't matter. That's not significant, maybe. Do you know the type of function exists? Okay. Um, do, do, do. Okay, in the absence of a question from chat, we might go back to doing the physics. Better sec. With complex zero differentiable, if and only if to be infinitely differentiable, and only if to be analytic. Okay, yeah, I think Territor was saying that in the YouTube chat, where like the condition is to be complex differentiable rather than just differentiable. Quote Newton, or rather Olivia Newton-John. Let's get physical. 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 Dude, why is this question the worst? I too much words. Lazy to read all. And the actual question is only this piece. The stuff that down here is just what the theorem actually is that they're asking me to prove. I had to go back and maybe read part of the chapter because I really don't. Yeah, like I also find figure 7.3 super confusing. Um, where these x and y axes seem to exist in the plane of the figure, and I can visualize how you could rotate the figure about those things, but it's just like I feel like they're never explicit about it. All right, see you, Storm. Thanks for hanging out. I guess they're drawing this distance in this way to emphasize that these axes don't have to be perpendicular. They just have to be parallel. In the proof that we're trying to do, we're simplifying it and making them perpendicular. I guess that's the reason why. Yeah, multivariate Gaussians and the volume change associated to them. Good luck, Jatsu. Oh my god. This distance is equal to the distance between P and CM if and only if the two axes are perpendicular to the line. Okay, so yeah, that's what they're saying in the parentheses. Wild things appear out of nowhere. Oh god, okay. Okay, now I'm still struggling. Well, let me. Okay, fuck everything about that figure. I'm drawing my own. Let's just call the CM there. Let's call the point P here. I still can't get over the fact that this theorem seems to be saying that the distance from P to an arbitrary point on this mass is the same as the distance uh, of that point to the center of mass plus the distance from the center of mass to P. Because that's what this seems to be saying to me. And that makes no sense. They are vectors, and that is a vector sum. I would love to believe that. But these R's aren't bolded. R is just a distance. They have some bolded things later on with torque. Like here, the bold r is the vector from the origin to the point for torque. But for moment of inertia, this r is not bold. It's very docile. It could still be a signed quantity. It could be negative, I guess. But I still feel like there's some geometry here that's being ignored. R squared is r dot r. I guess so, yeah. Like the magnitude of r squared is r dot r, yeah. So what if I just put my x and y axes there and say that the CM is at the point xy? Yeah, yeah, I know what you mean though. It's like that thing here. If the center of mass is at a point x and y, and point P is at some other x and y, is this too general? Should I put the origin? I mean, I don't want to bring trig into this. Hmm. Yeah, this just makes no sense. I'm like about to check the answer key to see how they should justify this because like I can't justify how this integral is zero either. Because I think it has to be zero if this construction is supposed to work. Because this piece of the integral, I think, is where your d squared m comes from. Or md squared. Which means that that piece would have to be zero. But like, yeah, so I could see how we could take the d outside of that integral, but then the integral of RCM dm, like, I don't know what that is. I feel like if you know that the integral of r squared dm is non-zero, how can the integral of just arcm dm not, like be zero? That seems like dubious, I guess. Everyone's over the whole area of the object, yeah. I think I'm gonna go and check the answer because this question just makes no sense to for like I so there's multiple parts of this question that just don't make sense to me. Definite integral of r squared equals 0 means value of r squared is 0. And as r squared is non-negative, it means it is 0 almost everywhere. Well, uh like this integral here for the moment of inertia should not be 0. For whatever reason, I'm getting uh that if you were to have just r the integral of just r dm, that should be 0, and I have no idea why it would be if we know the r squared dm isn't 0. Shouldn't this be 1? If that's the or, wait, the integral, or is this a double integral now, or is that what you're saying? I'm checking the answer. I don't care. So a special case, we have to explain the axis perpendicular to this plane. He is the origin of the coordinate system, general position of the CM of the object. R prime equals x prime right prime, be the point. Okay, so we are doing this as vectors. Okay, before I read the entire answer, that their construction makes way more sense to me. Wait, am I even remembering that right? Oh wait. Oh. That's um RCM is the vector from the origin that points to the center of mass. R prime is the vector that points from the center of mass to your arbitrary point. So the overall vector that we actually want R is the sum of those two things. This addresses the geometry concern that I couldn't get over before. Um, and so the integral of I guess this is where they use the vector, like the r dot r is r squared. Um, okay. Yeah, Emma. XCM squared plus YCM squared plus x prime squared plus y prime squared plus 2xcm x prime plus 2ycm y prime dm. Okay. Uh, do, 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 do. I should split these up differently. Like that. So this first integral is the ICM that we all know and love. Maybe. I hate it. Uh, this second one, that's the MD squared. Because this is basically the distance D. Did the where's the music? Oh, it's just a quiet song. This annoying thing. That's what I was struggling with the last time. it should be 0 if this theorem is true, which, you know, I think it's pretty safe to assume that it is, considering the book is saying it's true. Hey, why is that 0? What does it mean to have xcm times x prime integrated over the mass? I don't know. I think I'm gonna lose the answer key because I've already been thinking about this for a long time and I still don't know. um, what the hell is happening? X prime dm. Wait, why can the center of mass come out? I'm looking at this stage here. The center of mass can come out even of the other ones? Why? The two zeros in the third line appear to the definition of Cm. In short, equation 6.8 tells us that the integral of x prime dm over m is the x-coordinate of the position of the Cm, calculated is the x-coordinate of the position of the Cm calculated with respect to the Cm. What? Redefine the origin to be? You said the origin was what you're calling P before. In this set of the origin what you're calling P before, it was fixed in the Cm. Yeah, I think that's something to do with x prime and y prime being defined relative to the Cm. But x prime is pointing at P though. Like maybe my real issue is that this integral here is really vague to me. I don't really get it. I know that it's the continuous analog of this up here, but if you randomly take that r and switch it out for a fixed distance x prime, like I don't know, man. That's just weird. I don't understand what's happening if you just trade that r out for an x prime and you can somehow claim that it's zero. I don't get it. The above derivation makes it clear why the parallaxes theorem holds only if the CM is used on the right-hand side. Or associated with the position of the CM relative to the point we had chosen. So in the vector equation for RCM, the vector r and the RCM vector are both measured from the same origin. If that origin happens to be the CM, then both sides turn into zero. Oh yeah, this is the other song. Okay, yeah, sure. I guess if we put the origin at the center of mass, I sure would expect the center of mass to come out to be zero. The thing that I still don't like about it is that well, my argument is going to be I still don't like that x prime and y prime aren't r. I guess by how r prime is defined here, though. I really feel like it's using r in a different sense, though. Like it's in this problem, it's supposed like the r prime points to the fixed. Wait, no, it doesn't. It's probably used in a TV show or movies somewhere. It's end of line. It's not end of the line. It's end of line by Daft Punk. I need to look at the figure closer then, because why isn't the... Wait. Why is my view... Oh, Firefox is too fat for... the screen. Okay, I need to do that. If you guys want to see the figure. Because I can see it on my end, but I realized it wasn't showing up on your end. So I thought they're putting the origin at P. I was misunderstanding. Okay, now it makes perfect sense why those integrals come out to be zero. I guess I was misunderstanding how they're defining these vectors. And so the x, so my question before about why the center of mass coordinates can come outside the integrals is because they're constant. God damn it. I wish they gave us that figure. It would have been so much easier. It's really frustrating when I get a question miserably wrong like that. Okay. At my own risk, I'm going to bring in the figure that accompanies this theorem. This one's a banger. Illusions by C152. It's not bad. The company. So the thing that I had to that I really struggled with this figure because these x and y axes are in the plane of the figure or of the object, right? Like if I looked at just the upper part of this object, it would be like a solid of revolution from calculus. That's how I'm picturing this figure, at least. And for moments of inertia around the three coordinate axes are related. I mean, maybe a solid is the wrong word to use. It'll just be a flap or whatever. But it's like that same type of motion. We're not making a solid out of it, but and so I guess we're concerned about the z-axis that is coming out perpendicularly. Oh, they do say in the xy plane, the pancake object. This is not, that would be a crappy pancake. I would not eat that pancake. Okay. I would eat that pancake and ask for a second. It's not going to be evenly cooked. Pancakes should be circles. I mean, pancakes are delicious in general. But like I feel like something's gone wrong with the batter if it made that shape when you poured it in. There's no such thing as a crappy pancake. All pancakes are beautiful. You should taste my pancakes. It's kind of hard to nail a pancake in my mind. I found them to be kind of finicky. I'll put in like the wrong amount of liquid, and so they either come out too thin and just like spread around the entire pan, or they'll come out too thick and then they'll be too thick and not like cook through properly. You know, it'll be like a rare steak, but a rare pancake. Um. Okay, so I guess we want to make do. Can we make a vector r that's equal to Rx plus Ry. Is that the idea here? Unable to measure out quantities. I measure them out, and I feel like it comes out differently every time. It can't be my fault. Okay, it's everyone else's fault. Now I might get lazy about measuring them. Uh, bread is easier for me than pancakes. I can make some pretty good bread. I have some pretty good bread in my kitchen right now. Pancakes, I don't know, man. It's just the amount, like with bread, if you add the wrong amount of liquid, you can generally save it in some way. With pancakes, once the batter's in the pan, it's just kind of in the pan. I guess I'm saying it's an x coordinate squared plus a y coordinate squared. Is this one a lot easier than the other one? I guess that's my proof. I don't know. Oh, okay. I got it. I don't feel like I really understand what I did fully, but I did it. I did figure this out in my head. I should have said it. Um, but if you're using the x values, that's how you rotate around the y-axis, and using the y is how you rotate around the x-axis. I didn't say it. I mean, I should have flipped the order to if I was going to be exact, I guess. Um, okay, yeah, you did the same thing, Fembox. I was kind of like debating about the. I should have said it. Like I guess I didn't really conclusively like. I should have said out loud it, but even in my mind, I didn't like conclude. I'm kind of weird how you. I'm weird in general how you just like even forgetting about this situation, how you apply not vector R. How you apply the definition to weird misshapen pancake um when your axis is in the same plane. The distance, I guess you need a distance function, like you're taking the closest perpendicular distance. So like this point here corresponds with that distance there, and this point here corresponds with that distance there. But I guess I'm getting weirded out where the function is like it fails the vertical line test. Like that's the part where I get kind of weirded out with an axis that's in the same plane. I guess it shouldn't. I guess if I'm okay with a three-dimensional object being rotated around an axis, I should be okay with a planar object being rotated around an axis like that, right? Maybe I'm concerned about nothing. It's the same thing. I don't know. The little DMs are two-dimensional objects. It's actually a double integral in disguise. I wish they wrote it as a double integral. I wish that they made that more clear, because it doesn't look clear. Um, 7.7. I mean, that's probably what he does in the full book. I guess he's trying to be brief. Okay. Divide the object into a large number of tiny masses mi. Find the kinetic energy of each mass in terms of omega. Okay. So if we divide up into tiny masses, the kinetic energy would be the sum of 1/2 mi vi squared. The summation index is I. I'm not going to bother with trying to be more specific with a sum than that. I guess we should start by getting the velocity in terms of angular velocity, which is v equals r omega, I guess. So ri omega I. But whereas their velocities, tangential velocities, aren't all the same, their angular velocities are all the same. Okay, I think I see where this is going. Because we're going to group the m sub I and the r sub I squared. And miri squared, well, the 1/2 in omega squared can come outside. And that's the moment of inertia. That's summation. Random question: is the absolute value of y equals sine arc cosine of x the equation of a circle from Papadoria? What the heck? Is it? Just want my headphones. I think right off, well, if the absolute value of y is equal to this thing, I think we can only take positive values of the right side. Papadoria's come to torment my peace again. Yep, bucks. Sine of arc cosine of x can be simplified. Oh, it might be. I guess like arc cosine. Arc cosine of adjacent over hypotenuse is an angle. So sine of this triangle is just root x squared minus 1. You graphed it and it was a circle, but you're wondering why. It's because of the thing I'm doing right here. Yeah. You see it now? Wait. No, this is hyperbola. This is hyperbola. Oh no, I'm doing this wrong. I'm doing this wrong. I'm doing this wrong. I'm doing this wrong. It's like, why am I getting a hyperbola? It makes no sense. There we go. This is right now. That's why. 1 plus x squared? Oh no. I made the mistake too. And I mean, I failed the Pythagorean theorem too. I reversed the order. I was so confident. Why was the pirate such a confusing trigonometry teacher? Because he kept saying arcsin. Oh my god, Mega. That's terrible. You came to ask as you were so stuck. Oh my god. Hey, you know, if you want to make all your questions on this level, I will be very happy, Papadoria. But that does kind of raise a question with me. What happens if you what is the absolute value part of that y? Or like what's the absolute value part of that doing? Really? That makes it a complete circle? I would have thought the opposite. What? Oh. Oh, I get it. Yeah, no worries, Papadoria. Yeah, I guess I can see it. It's pretty like I can see it really clearly here. It's just harder for me to see it when it's something more complicated. But yeah, I could remove the absolute value and put a plus or minus. And yeah, okay, yeah, fair enough. I was thinking that like no, I don't know. I don't know what I'm thinking. I should stop thinking. I think I actually did number 3 right for once in my life. Um. Do, 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 do. Yep. So my goal is to try to get through all 8 of the foundational problems here. I don't know. I don't know if I'm going to accomplish that before the end of the stream. Let's see if I have another existential crisis over one of these questions like I did with number 1. For with translating and rotating Sherlock kinetic energy to govern by equation 7.8. Ugh, stop making me look up equations. 7.8, where is it? It's that one. You don't think that was the real Papadoria? That question wasn't nearly evil enough? It's a good point. Maybe Papadoria has an imposter. Really? Essential crises are the most fun to watch. Makes for a fun stream for us. Oh, good. Hope you help use the. Really? Wait. I thought I was gonna get to say that the total velocity is equal to the tangential velocity plus the rotational velocity. How do you say tangential? Is it, do you use the perpendicular sign? I think it's that. What is that good or bad? Or is it in the middle? I guess these are vectors. That's why this is bad. Or I'm a seal. We can let vector v be equal to tangential vector plus rotation. Dude, how do we notate this again? I need to go back to is it here? ATAR for radial and tangential. I guess. Okay. Is it a radial velocity though? I think. And so this v dot v is I need a vector identity here, don't I? Uh, how does the dot product distribute like that? I shouldn't go off the beaten path of what the hint is telling me to do. Oh my god. A dot C plus A dot D plus... Okay, so it does distribute like that. Underscore is confirming. Okay. I don't know. Oh, wait, maybe this is a good idea. Oh, wait. Yeah, because we're going to get zeros for the dot products that we want to get rid of anyway. Aha. I'm on to you, Morin. Because this dot product that I'm writing right here, it's zero. These things are perpendicular. So this v squared is also equal to vt dot vt plus vr dot vr. So we get 1/2 m. Wait. I need to somehow sell that my VT is that VCM. That's probably a way to do it. I feel like it should be. I just don't have the words to justify it right now. And then VR squared is r squared omega squared. I don't know why I'm saying it like that. Now every piece the tangential velocity has to be the same. Or tangential and radial components reversed, but it doesn't matter. Really? I want to do it right, though. I think I'm... Yeah, well, which one is which? That's not so simple. I need to really think about what this VT and VR are, because Morn is really using this stuff with acceleration, not with velocity. Um, you know what? I think I am doing what the hint is telling me to. I'm actually this is the intended way of doing it, I think. I just should rename my subscripts. VCM plus whatever rotational velocity. Okay, wait. If you have an object that's just moving in a circle, though, its acceleration, or like the acceleration has a tangential and an inward piece. But isn't the velocity just tangential? That's what I'm getting tripped up by. If it's only rotating. I think I was slightly wrong by saying the tangential and rotational piece. Like the acceleration has those two components, but I don't think there's an inward velocity component. The acceleration has the inward piece. Yeah. I was cooking a little too hard, but it was the right... I was in the right ballpark. Um... Nice. Okay. How do you know VCM and VR or are orthogonal? Uh, it's true. We should assure ourselves that it's orthogonal here. Um, I think the image. Ooh, is this VCM thing three-dimensional? If it's three-dimensional, then I think we're just completely fine. If it's if the rotation is only in the x and y plane, in the velocity is in the z plane, then we are always orthogonal. Does it? It doesn't have to be like that though, right? You could have translational velocity that's not in the direction of the axis. You like torque, Tyler? I don't remember learning about torque at all, to be honest, in my physics classes. I mean, I no, I think I remember it a little bit. It just anytime rotational stuff gets involved, I get a little lost. VCM is the speed of the center of mass. Oh, it's because we're specifically so this only holds if the velocity is also the axis of rotation, or the translational velocity has to be in the same direction as the axis of rotation. Otherwise, this does not hold. I think that's what this like paragraph down here is saying. You get something that's a lot more complicated if it's not. That's like the last sentence. Well, related to high-powered cars and trucks. So yeah. Ugh. I'm not even a car guy, so I just never enjoy it. Okay, so that's how we assure ourselves it's always orthogonal. 7.4. Let's go check the answer. Similar reason for that term canceling as the term in problem 1 canceling had. I, I thought Wait, where are you reading that? Or oh no, that's your sense. I think the problem one cancellation is for a different reason though, or maybe it's not. Oh no, you're right. Yeah, I think it's the same reason. Horsepower is how fast you hit the wall. Torque is how much of the wall you take with you when you hit it. Okay. Oh, I'm supposed to use the integral definition. Wait, I never used an integral or a summation. I guess. Wait, what? I've never seen this definition. Do they say this definition of kinetic energy? No. I guess okay. Yeah, I guess it's fine. Um, I was doing. Was I? That wasn't the last. No, the something was the last problem. This one I wasn't. I just went straight from 1/2 mv squared. I don't see the difference though. I don't know why you need to go to like I don't know why you want to express kinetic energy as an integral over mass. Oh wait, I see. Okay, the second I canceled them for the wrong reason. Okay, I canceled it for the wrong reason. It wasn't a dot product reason. Hmm. Okay. I really wanted to do all 8 problems, but I feel like I just ran out of brain power here. Uh, yeah, I think I need to call it here because I didn't realize it had already been 4 hours. And I kind of want to give my mind a break. So I think that's what we're gonna do. Um, But yeah, I guess the YouTube stream I'll cut off here. So anyways, here on YouTube, thanks for being here. Plan to be back on the stream. The audio stream's current bitrate 0. What? No? Okay, audio's coming through. I don't know why you're telling me there's 0 audio bitrate, YouTube. Okay, anyway, if you're here on YouTube, thanks for being here. I'll be back on Tuesday.